Hello, welcome back to BackBit Impawsible. It's Luke Darksnow again, and this episode is my victory. The 3-byte solution, and yes, the most confounding thing has been solved. In this episode, I go over exactly what was going wrong and why, and it's pretty much a single take episode. I get home, I try it out, I start recording, and then I just talk and talk and talk. But hey, it's great. I mean, if you can follow along in your imagination, because I don't think I made any overlays onto the screen to demonstrate the things I'm pointing at. But well, if you follow along, it'll hopefully make sense to you, and you'll get an understanding and appreciation of the whole problem, just like I did. And well, I guess I talked enough. So let's get to it, eh? All right. Okay, well, I'm home. I tried the fix already. It works as expected. Check it out, and we're slow. Don't worry. Watch. No green. Ta-da! Yeah, this was crazy. And like I said earlier, the satisfaction I feel for overcoming this, the thing with solving a bug, it makes you a better programmer, ever so slightly. And in this case, I feel like I have a bit more control over, my computer, over what I'm asking it to do, because I didn't fully understand the implications. And, well, how does it work? Well, I can't even show you anymore because, my source is destroyed, right? That's how this works. It's only going to get so far, and then it's going to turn to gibberish. And that's all she wrote. But, man, okay. The fix, I realized, is actually visible. And here it is. This quick fill. At the very beginning, I want to fill buffers 0 to 4 and 5 to 9. Now, quick fill originally was a double routine. It would fill 10 buffers in a row and get them all queued up and then leave. But later on, I changed that because I wanted my main loop just to be able to call it as well. So I turned it into a single, where it only does 5 buffers at a time. Thing is, I never fixed it earlier. So as you can see, well, 971 I stuck in here, right? But, okay, let's try to explain how this works. Boy. Okay, there, we can see the whole thing. Now, done check down here, don't worry about it. Time, I'm going to get rid of that, I don't need it. So basically, when the main loop begins, well, the initialization fills buffers 0 to 4. And it sets the next raster, the next frame update to a value of 1. So as soon as the first interrupt comes along, it decrements that value, sees a 0, it knows it's time to introduce frame 0, because that's what current frame is set to. So it goes ahead and looks up frame 0, sets it properly, does the color routine, sets the next frame to play in 2 frames, because it's a 0, it shuffles it over to create the carry, adds 2. So sometimes it's 3, sometimes it's 2. So the next one is due in 2 screen refreshes. Big deal, because the main loop is waiting until it's at buffer 5, until buffer 5 is the next to be displayed, because it thinks this and that are both in memory, but they're not. It's just this one. That's my fault. So by the time, okay, so it's basically, it plots the first one, great, and it's still looping, plots the second, plots the third, plots the fourth. Now the fourth is an even number, so you shuffle it over, add 2. So 4th to 5th, it's a 3, it's 2 more ticks over to number 5. And once it ticks over as to current frame is 5, this now sees, well, carry is now set. It drops down, and it's not filling buffers 0 to 4. It's filling 5 to 9. But in two. screen refreshes, it's already supposed to be displaying buffer 5, and it's not even in memory yet. Oh, but the thing is, the very first buffer is a toughie because it has to do pretty much the whole screen, 1,000 color RAM thingies, and it does take a frame to do. But by the time you get to frame 4, lucky for us, it's very, very similar to frame 3. So little has changed, right? So the color is in and out in a flash. But when it flicks over to 5, well, this no longer loops here. It's doing the quick fill. And the quick fill routine is actually a queue up of the video, like on the BBT, and then it brings in and, well, it doesn't bring it in. It queues up the 64K exactly where we want to start and executes 225 pages of that in a row. Executes it. So like the first 45 is actually dedicated to frame 5, which is good because we load with a 0. We write all the things that are 0. We load with a 1, write all the things that are 1. And once we get to 255, only then on the 46th page do we, well, I guess it would be the 45th, right? Because 0 to 44. But on the 45th page, is it bothering to do the buffer number 6. So it loads 0 into the whatever and gets ready to store all. So by then, buffer 5 is now done. Lucky for us, because after frame 4 is finished, it's maybe around here, and it starts queuing up the data. And by here, it's now less than a frame to go, give or take, right? By the time it gets to here, again, it's going to be playing buffer 5. That better be in place. And by then, luckily, almost always, I haven't had it happen otherwise, buffer 5 is in place, which is good because it's the only thing that stops it from completely hanging. And as you can see, or have seen, when I did use the Super CPU and I set the amount of screen refreshes to the next frame to 1, buffer 5 was not full, was not ready by the time it was told to play it. And I'm willing to bet it was hanging on, well, the character set was not completely in place. That's why you get a mismatch of what's there and what's not there. And the part that kills it is the color RAM is not set, like the packed color. So at some point, it's going to come across a value that sends it back. And now we have a permanent loop because it's doing that in an interrupt. And that's where it hangs. But normally, it's already done. Great. But here's where it screws up. Now, this is the tricky part because the wait delay for the BackBit queue-up is unknown. Sometimes it can be as fast as 5,000 cycles, but because my card is wearing out, it could be 20,000 cycles. That's more than a frame. So in some cases, let's say from 4 to 5, well, let's say it happens down the road, because if it happens on the very first run, frame 5 is going to kill it. But after frame 5 has data in it, you're safe in a way, because say from 4 to 5, it's another 2 cycles. And this is the weird part, because after it plots these, and it's still drawing them out, by the time it gets, and it waits until it's done frames 5 to 9 to fill 0 to 4. So once again, we're back to the same problem. From 9 to 0 is 3 screen refreshes, because 9 is odd. You shuffle it over, carry set, add 2 becomes 3, raster count becomes 3. 3 screen refreshes until buffer 0 is due to play. So you're more likely to get the glitch here versus the wraparound. But in any case, let's suppose it happens and it jumps over. It goes to fill. It has to queue it up on the BBT, start filling frame 0. But if it doesn't fill frame 0 entirely, by the time it's due to play, the interrupt kicks in and the video, the character set and the video matrix get slammed into place. It don't matter. Those are just visuals, right? It's the routine that unpacks the color That is the problem. Now, the trick of it is, the beauty of it is, it already has data in there. So, and you've seen how it works, where if it's a positive number, it goes ahead. If it's negative, it plots it. Negative, it plots it. If it's positive, it'll jump ahead a certain amount. And once you get to the 127th value, it's always a negative. I made sure of that, because after it plots, it advances, y becomes negative, and now we're looking at the negative, or the next 128 bytes, and decoding it in the same way. But once you have this down one time, you can start loading, because the way the routine works, the rollout code, it'll take a 0 and put zeros everywhere zeros might be. And in the case of my unpacker, there's no zeros. There can't be, because it'll loop endlessly. It's just not cool. And I'm sure it doesn't, but it'll start with the ones, wherever ones need to be. Well, the only place a 1 can be is actually here, but don't worry about the logic of it. And by the time it gets to like the higher numbers, like anything negative, it's already halfway done everything else, because at the same time it's filling the character set, it's filling the video matrix. So let's say it's doing the rollout for 136, and then the interrupt kicks in. Well, anything that's how do you explain it? Maybe you can already understand with me, though. As you're plotting new information down, it works. Even 134, for instance, might be here, it could be anywhere, wherever that specific color is needed, right? Well, actually, no, because 128 plus 8, 136 is the absolute minimum value you're going to get, because they both, bits 3 and 7, both have to be set. But in any case, when the packed color buffer is neither here nor there, it still is impossible for it to loop on itself endlessly. And it's also impossible to not eventually, through pure chance, make its way to the 127th character value and split to the next bit and finish the thing. But in the meantime, it's plotting stuff that is possibly from the last time 10 frames ago might have been there, because it hasn't updated that and covered it over. The interrupt don't care. It sees that, it executes that. And meanwhile, so when the interrupt's done, the rollout code continues, and it happily finishes what it needs to, but by then it doesn't matter. And there it is. That is the mystery of why colors sometimes appeared where they shouldn't have. So why does giving it one extra frame between screen refreshes, or between frames, one extra screen refresh between frames, why does that make all the difference? I'm giving it more time to complete that very first buffer before it's told to display it. And it's only because I was stupid and I was one quick fill away the whole time. So I was actually running on a razor's edge by only having the first half done when I meant to fill all 10 and then wait until it's here and then quickly do this. But instead, I wait until it's on number 5 to fill number 5. Talk about crazy. Okay, so now do I have this in place? No, because this is going to completely crash. So what we're going to do here, now I'll show you something neat. Well, I still got you on the phone. So we got to do this, switch it over. Man, I got one paw again. Final 1.06. Now, I do have 1.07, but don't worry, it was just a stupid hack. Okay, what do I need to do? So, 970. Well, let's fix the bug first, right? So we'll just duplicate this at 971 for now, nice and crude, not 972, or I screw stuff up. Go to 6200. Where are we? Now here, I'm acknowledging the interrupt early. At the moment, I don't think it's really making a difference. But here, never mind, see, like here's where the current buffer You see I shuffle it over to create the carry, so it's either a 2 or a 3. But I can just overwrite the whole thing by doing that. Haha, now you're stuck at 1. Now there's a reason for this too. Now what I'm going to do is show you that it doesn't choke at 20 megahertz. Well, I'll wait till it's done assembling. There we go. Now there will be some side effects, and I understand that as well. So here we go. 20 megahertz, and is only given at 1. Well, look at it go. Now there'll be glitching because the same effect is still happening. The interrupt is just going frame 1, frame 2, dun, 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 and it doesn't care what's there. It doesn't care if it's ready, but it's signaling the main loop. Fill this, fill this, fill this, and the main loop's going, oh, it can't keep up, right? So sometimes you're going to see stuff that is glitching because it's showing it as it's filling it. It's kind of like when you've seen a guy put down the new billboard. He'll plaster the first paper, then the second paper. So imagine frame 0 is being shown, then frame 1, frame 2. Those are the filling, but the routine doesn't care. The interrupt is just going, take a picture, take a picture, take a picture. It doesn't care if it's ready. So what we're going to do, now we'll do it at slow speed. And you'll see a great difference here because it's still showing the buffers at a difference of 1. Actually, it'll interrupt itself because it's allowing itself to, because I acknowledged the interrupt early, which isn't very wise because a certain pointer is going to get, oh, it's going to be a mess. But watch when they zoom into the tree after she sees the berries. It'll go beep, 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 beep. So you watch, it'll be a bunch of times. Come on. You see that? Because while it's loading in those frames, it's just going show, 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 show. And you can imagine these are the frames of zooming in. So it zooms in what it has, and by then it might be a frame or two forward, and it zooms in and it shows what it has again. So it's glitchosaurus, right? But understandably so. And even this, because I do have it count so many refreshes before it, not refreshes, every time the buffer goes from 9 to 0, it counts that. After 873 of those, it ends the video. Whether it's displayed it or not, it doesn't care because it will end early now because it's basically done that 873 times. Whether the frames were loaded or not, it don't care. So sometimes it misses the entire queue. Like it might load these, and by the time the main loop goes back, it goes, no, and it loads those again. It's neat. But this is just me being stupid. At 1 megahertz. Neat. And that is crazy fast. And it's still not good. But at 2 refreshes in between, oh, I can't even get out of here. Oh, did you see that? She was freaking out. Okay, let's try the 2. Oh yeah, let's see. And I love the fact that I can now use the Super CPU with this because everything's executing from the BackBit. I tell you, I did not know that that was a thing. So the whole time I was being super cautious. You remember all that. 6200. I got to remember where these lines are. Let's see. There we go. So let's just make it 2. Get rid of that. Well, we don't have to worry about that. Well, actually, no. Yeah, this will work. It doesn't even matter. Assemble fast, please. Go slow, and away we go. 2 screen refreshes. We're not going to see any green, no nothing. It's just enough time for it to keep up at 1 megahertz. And it will now because buffer 5 came in nice and clean. And there's no problems. But if I ran it at 20 megahertz right off the bat, it probably would have crashed, but now it won't because there is information in buffer 5. You see? Well, actually, it's not going to crash at all because of the fix, right? But before, the fix was because of that. Or the crash was because I didn't have buffer 5 ready. but now I do. Anyways, I hope you understood at least part of that, or at least, at the very least, understand my excitement and satisfaction that I got it done. So now, I got problems. My next questions are, do I want to wrap this up and get the video going, or the audio going, or do I want to handle this flickering grass problem? And the way to do that, possibly, is go back to my original bitmaps. But I could compare one bitmap to the next. I want to try that and see how many bytes change. And if it's a low enough number, kind of like how the color, when the scene changes, a lot of color needs to get written, but between frames, very little. Maybe that applies to the bitmap as well. And if I'm able to keep up, although memory is going to be tight, if I'm able to keep up, perhaps I can pull this off. But that's complications I probably shouldn't even try, because this does look good enough. The goal will be a success. But yeah, I guess we'll see what I end up doing, right? And of course, if I do go ahead and do the bitmaps, I could probably, for the cost of 1K, throw in a new video matrix. I could redo the maps with better colors. It can be beautiful. And why? Why bother? Well, because I can. It's a coding adventure. Well, what day is it today? January 30th, 2024. Hooray! Well, I'm not going to mark this on my calendar or anything, but I am going to remember when I got over the most confounding thing. Well, in the next episode, I think things get a little back to normal, because I do take one more stab at solving a different problem, the flickering grass issue. Now, you've seen this thing rear its head time and again in previous episodes. Well, this time I'm tackling it head on. This is my goal. Can I reduce or eliminate the flickering grass? In the next episode, we'll find out.